let's hit the record button and then immediately start eating.
Got to get my gains, man. I need my overnight oats.
So we're going to be talking about quality today, excellence in quality control, and we are the biggest hypocrites ever because our quality control process for our ad reads is laughable. And by laughable, I mean like we are falling over with our stomachs hurting, just about ready to cry. We were laughing so hard. Overall, the experience was very SWIT.
The quality was not SWIT.
And for those that weren't there, like everyone in the audience, we're doing an ad read, and Mike's showing us this fixture from S&W Autoblock, and Paul, his time to shine. And Mike goes to him and he says, "Wow, Mike, that is SWIT." And I just said, "What the hell is that, man? What is SWIT?"
I'm trying to make a new cool word.
Yeah, it is. Well, it is now. So if you are listening to this episode, if you reshare it with hashtag SWIT,
bonus points.
Bonus points. We'll do
that,
something.
We'll send
we
you
don't
a
know
sticker
what it
pack.
is. Yeah, a sticker pack. There you go. Here, and just so you know, it looks like this. If you're on the video right now, here's the lights out sticker. We got them for every one of our shows.
There are a lot of manufacturing events out there, but Top Shops 2025 happening November 11th and 12th at the NASCAR Hall of Fame in Charlotte, North Carolina is the one I'm circling on my calendar. You know, as a motorhead, I'm thrilled for that. It brings together the most forward-thinking shop owners to benchmark, share ideas, and dive into what's really driving results. And this year, Nick, Mike, and I will all be there. We'll be on site having real conversations with leaders like you and bringing that energy back to Making Chips. Registration isn't open just yet, but if you want first access to all the details, head to topshopsevent.com and sign up for updates. This is going to be big, and I hope to see you in Charlotte.
All right, so achieving excellence in quality control. We'll be honest, Paul put about 95% of this together. So we'll just participate the best we can.
I've learned all my best practices from Paul. So
yeah, same here.
Well, I've only know what I know because I made so many bad parts in my day. So
right.
Piles and piles of bad parts.
Well, let's jump in.
Yeah, but seriously though, you know, every shop says they make good quality, right? And it's paramount. It's like table stakes to even like be in the industry.
Mm-hmm.
But it's making good parts is a lot more than just trying to machine a part in tolerance, right? There's way more that goes into it, from even your quoting process and making sure that you are not quoting things you can't actually measure or don't have the machines to make.
Mm-hmm.
I definitely know of shops, and probably have done it myself, that I've mentally blocked from decades ago, where we quoted a job and was like, oh my gosh, we can't actually make this right.
Right.
You know, we cannot make this tolerance. And it just absolutely kills you, right? You spend days and days trying to dial it in and may eventually never get there or finally get there, but you lose 1,000% on that job.
Yeah.
Right? So
it reminds me of Mike's tagline for Hill. You know, it's anyone can make a quality part once, but who can deliver a quality part on time every time?
That's a lot of work goes into that.
Yeah, exactly.
Yeah, it's funny when we had that, we started that tagline, you know, it was like there was this startling pushback of like, what? You know, we can't do that. It's like, well, we damn sure better be able to do that. Right? I mean, the every time is the part that kills you, but
Mm-hmm.
that was actually put there on purpose because you're going to have to continually improve and follow your processes to deliver quality parts on time.
Yeah.
Yeah. No, it's great. Kind of hold your own feet to the fire.
Yeah.
And it starts way before you're cutting any chips.
Absolutely. Yeah. Both on quality and on delivery. Like the other thing that people shoot themselves in the foot for all the time is they quote a lead time they can't actually do.
Mm-hmm.
And then they cut corners, maybe in quality, and then it's just a big cluster. So yeah, first big point is make sure you can do it. Just be a little more thoughtful when you're looking, estimating. Go talk to your quality team. Hey, we're quoting this part that looks like this. Go talk to your programmers. How do you think you'd make this and hold this tolerance? And just make sure you got a plan for it. The next thing would be when you win the order, make sure you have the correct version of the drawing. First of all, please don't make parts off the wrong drawing or model. So that's a quality check you should be building in. And then start the quality planning process right away, right? I know way too many horror stories of shops that they program the job, they get it to the shop floor, they buy material, they're making parts, and then it shows up in quality at the end. And that's when they start looking at the drawing and developing the quality plan. It's like, oh, we need to do a final inspection on this, a first article. And it's way too late at that point.
Yeah.
So you gotta start that early, and the quality folks must collaborate with the programmers or the manufacturing planners that are deciding how to make the parts, what cutting tools, what tool paths, which side is going first and next, because that manufacturing plan cannot be separated from the quality plan. They are one and the same, right? If you're machining these surfaces with this type of tool and this end mill and this face mill or this drill or this tap, that should absolutely define how you build your quality plan.
Yeah, and even how long, like when you're routing, like how long each step of the process should take. Like if you're doing a manual quality check, and what's in my mind right now is we make these precision spindle shafts, and we have to use air gauging to be able to, like, we're checking the inside of a tapered spindle shaft, like where the tool holder goes. That's like super hard to check manually with like bluing and all sorts of crazy stuff like that. So the difference between like using technology to check it and doing it the old fashioned way is hours and hours and hours. Are you considering that?
Mm-hmm. Nick, you could just cut those down the middle and use an optical comparator.
Yeah.
Just do that,
and then
re-weld them
just glue
together.
them back together. It'll be perfect.
It'll be great.
I'll see what the customers think about that.
It'll be sweet quality.
It'll be SWIT.
It'll be SWIT quality. That's right. So yeah. Anyway, that is important, and specifically when the way actually with the way we always thought about it at Pro CNC and the way we built some features into ProShop is we identify which cutting tool is cutting every finished dimension. And then we make sure that for height and diameter is being checked in the in-process, of course, the first article, but the in-process quality as well. So if you have a tool starting to wear or starting to, go out in Z or in XY, then, and I'm talking about milling terms, then you can check it. And you will find it, as opposed to having something that you don't realize you're not checking that tool, and then you make lots of parts, and you realize that it went out of tolerance 20 parts in, and out of an 80 part run, you got 60 bad parts. So that's not a good thing.
What about the tension between like in process inspection, like probing during like in the machine versus
That is
taking
a
it
bad
out of
day.
the machine? And there's some tension there too, because like you're not getting parts out as quick when you're using some of that time to check it, but also if they're wrong, you're screwed, right? So it's interesting how you make this trade-off decision.
You got to get good parts out,
depending on whatever work you have.
Mm-hmm. And some people say you shouldn't be checking it with the same machine that you make it, right? If it's cutting it bad, it might be measuring it bad. I think that argument does hold some water, but for the most part, they're probably going to be pretty good. But I think it just depends. You think a mixture of both, right? Sometimes probing doesn't take a ton of time, and you can really check something super well that would be hard outside the machine. You don't have a CMM or a shop floor CMM or some way to check something that's not as easy as just some gauges. I think that should be a healthy debate in the quality team about the entire process from front to back and how you check it.
So speaking of the quality team, is that a unique business function? Like, is that its own function? Like you have a quality, or is that part of everybody's job? Which of course the answer is yes, it's part of everybody's job. But like, who should quality report to and flow up to on like an organizational chart, in your opinion?
Gosh, I've never actually thought all that hard about that. I'm trying to think back at Pro CNC. I mean, the quality manager just kind of reported to the CEO. We weren't that big an organization, so it didn't, not like we had multiple layers of management. I get the argument that, that the quality team shouldn't report to like operations because they're incentivized to just get parts out. But ultimately if parts come back from the customer because they're bad, that's a huge black eye on operations. So
yeah, the fox watching the chickens.
Yeah, exactly.
I think that it comes down to like even the last thing you were talking about is like, well, what are you measuring? Should you probe in the machine or out of the machine? Like, what's your KPI? Like, what are you measuring in terms of your business performance, not just the part? Because if you use a metric like OEE, it's going to factor quality into part of your overall equipment effectiveness. That's part of the equation of OEE. If you miss that, then
they're not good parts. It doesn't count.
If it's just if it's just about spindle utilization, you can win by making tons of scrap. So
I've stayed pretty adamant at Hill that, I mean, whoever my inspection manager is part of my management team. I mean, so we've got 5 people on our management team that cover different buckets, and inspection stands alone. All 5 of those people report to me. Yeah, obviously they have to work real closely together, very closely together. But yeah, I mean, if it's it's the lifeblood of who we are, is making good parts. Like, I think it needs that level of management. I've been in other shops where the entire inspection department is maybe one person that's almost like, from a pay scale standpoint, on the lower end of the pay scale, and they just fill out paperwork. Maybe that works for them. I don't know. Like, but to me, that needs to be like one of your key people, and you need to have somebody that is key to your entire infrastructure of your business, that quality is their responsibility.
Yeah. So for us, Josh Green, shout out to Josh Green. He does an incredible job. He's our director of quality and continuous improvement. So
I love combining those.
Yeah. Everything that is continuous improvement. Because, like, let's say there's a quality problem, right? Okay. Well, it's not just how did we check it or how was it made. The root cause analysis sometimes goes all the way back to like sales. It's sales inputs or whatever.
Oh,
right?
yeah.
So it's like a full function. It's a full cross-functional team for continuous improvement. Well, quality, could be influenced by functions that are way outside of operations. So,
yeah, and I feel like you need a leader that's thinking strategically about quality at all times, not just the daily checking of parts. The process of how you inspect, of how you control things. Yeah, who does it, on what frequency, what tools you're using, the calibration, just all of it, right? So, yeah, because it's so foundational, it's got to elevate to a little higher level in the org chart, if you will.
Yeah.
In my mind. So the next critical thing, when you're doing quality planning, you got to then have something that you have on the shop floor that you check against, right? And that would typically be the drawing. Now, there's more model-based definition stuff happening, but let's be real, most shops are still checking parts on 2D drawings.
Sure.
Of course, we're huge fans of only having a digital version of that, not having a paper copy, because things happen to paper, and it can be the wrong rev, and then you're, all the problems with paper. But uniquely identifying every attribute is a requirement of like AS9100, for example, but I think it's a best practice overall, even if you aren't ISO or AS certified, that you need to identify each attribute you're checking. Because if you have, a part with, let's say, 3 dimensions that all happen to be half an inch, when you're reporting that, how do you know which one you're talking about, right?
Yeah.
So which half inch? Is it the depth of this slot? Is it the length of this boss? I don't know, unless you have a unique identifier. And that's where balloon tagging, really comes into play. We've always been really big fans of HiQA. Think they're an awesome software product, and we kind of partner with them, and many of our customers use it. I think you do too, Mike, right?
Yeah, it's a real important part of our whole tech stack. I mean, just, the ability to take a print, put it in there, identify all of those, and then assign them out to, each operation level I can't even imagine how much time it's saved us and accuracy over the years.
They have the best OCR from what I've seen, which is why we kind of partnered up with them originally and just started recommending them to our customers.
OCR again for me?
Optical character recognition. So it's like you pull
like
up
when
a
you
PDF
scan
drawing.
a business card and it like puts it into your CRM or whatever. Got it. Yeah.
So imagine, a geometric tolerance block with true position and, maximum material condition and all the datums. Like, that's hard to recognize and know what's going on and how to put that into a quality plan. But their software does a great job of that. And then we can just import all that plan right into ProShop into the operations that you need to.
Now, is it doing that like you take a photo of the drawing, or does it right from a PDF?
You just upload the PDF.
Yeah. Well, you
And
talked about paper, and like my first thought was Gary and Klaus from the Lights Out series. Gary's struggling because he's got piles of work in process because he's not running like one piece flow at all, and then he's got paper travelers like mixed in the piles, and then they get covered in oil, so you can't read them. I mean, this is all stuff we've seen before. And why you're so adamant about like forget the paper, and OCR is not going to work if it's covered in oil,
Yes, indeed. So load it up, do the quality plan, import it in so you have you have like an inspection plan for each operation, right? All the machining operations, assembly operations, grinding, and even outside processes, right? You need to have an outgoing inspection process, an incoming inspection process every time something leaves your plant, right? How many times do you send something for anodize and they racked them on the threads and now the thread gauge doesn't go? Or there's a bunch of chemicals and, goop down in the bottom of the threads and your gauge doesn't go far enough.
Well, I'll tack on that because this is something we've definitely fought many, many times over the years, but outside of just the quality perspective of doing a good outgoing and incoming inspection is how many times something's come back from outside processing and all of a sudden it's wrong.
Sure.
And it may or may because we maybe didn't do a thorough outgoing inspection, we can't prove it happened at outside processing either, right? So you kind of end up on the hook.
Yeah.
So just as a good practice, like you need to document what you sent out so that you can document what you got back and maybe protect yourself on making new parts or sending them back out for outside processing again or something like that.
Like every tombstone we make, we check with a monster CMM and then we ship it because like, how you made the point, Paul, like don't use the same machine to check the parts.
Yeah.
Half the times they're like, hey, this tombstone's out of perpendicularity or whatever. It's out of tolerance. We're like, here's the CMM report. Check your machine, and it's almost always the machine's fault. But like that's kind of an interesting thought on outside processes. How often is quality the outside process? Like if you don't have a CMM large enough to check your parts, or if you don't, like, do you send anything out to get checked, Mike, or is it all done in house?
The only thing we would potentially send out that we do a few times a year might be some of our weld testing where we've got to go do some sort of non-destructive testing that we don't have in house. We do some in house, but if it's got
some kind of X-ray or penetrant or something,
or dye penetrant, sometimes they come in house. Sometimes we have to send it to them, depending on the size of the part and stuff. But all of everything we machine, we do and we're able to inspect in house.
Should every shop owner aspire to keep quality in house as much as possible? You have outside services, right? But like quality,
it's logistically so hard to iterate on. If you're sending something out for CMM checking, and you don't hear the results for 3 or 4 or 5 days later, you're like, you're just kind of dead in the water, and then it's like, okay, we need to make a small tweak. Then what do? You make another one, send it back out, wait another 5 days.
Right.
Like that's untenable.
We do some contract checking. So if you're one of my customers that sends me something to check on my CMM, just ignore everything Paul said. Okay? It's a great idea. It's a great idea. Keep sending us the work.
Should have run that answer by you, Nick. Sorry about that.
No, I mean, I totally agree with you, actually.
Yeah, so that's it's a great little topic to cover and check off. So fundamentally, when you start getting into the machining of the parts, which is what most of our listeners do, is you must validate your first part off, right? Your first part inspection, your first article inspection, whatever you call it. Although there is nuance to those terms, like the first article is the inspection report you send with the parts. And whether that's the first part off or just the first good part off, or is it the same part for all the dimensions, or is it a representative part? I don't think we have time today to get into all that detail, but basically validating that the process has made a good part, and then having an in-process inspection plan to check the parts as you run production, right? Some kind of frequency, some kind of statistical process, and let's be real, most shops that do small volumes, job shops that are doing 10 to 100 parts, you don't actually need statistical process control. You just need to check enough parts to know that your process is stable, right? You're not running regressions. You're not doing all that crazy math stuff. It's just like
CPK.
you got 100 parts. Yeah, CPK and CP and gauge R&R studies. If you start getting into the tens of thousands or hundreds or millions, and absolutely, of course, that makes a ton of sense. When I did consulting at Microsoft for Surface devices for about a year, we absolutely did all those things, but they're making like 1 million Surface devices, so you got to check that stuff in that way.
You mean like the Surface laptop? Like mine? Oh,
yeah.
Paul, consultants for Microsoft. Wow, you just get more brilliant every day.
It's a long story. Maybe we'll cover it in another episode. But my shop did a bunch of work for Microsoft, and then we got into DFM consulting with Microsoft, which turned into process consulting, which turned into 15 trips to China for me over a year.
Wow!
Oh my gosh!
So that was fun. It was interesting. But yes, you got to validate the parts. And the way we think of it is that the setup machinist should do the first part check. And then based on your shop and your resources and your team, they should either, be qualified in whatever way you determine that to be the final check, or you should absolutely have a peer of theirs double check their work or send it into the quality department if you have a full formal quality department, right? And there's shops of all different sizes. Some have full QA teams, some don't. But, validating with a second set of eyes, second set of gauges possibly is a really good idea. If you can.
Yeah, we send everything. So every machine setup, we expect that when it goes into inspection, the machinist has checked it and says, I know this is a good part. Goes into inspection, gets the second set of eyes with different tools. In some cases, totally different tools, right?
Sure. And does the machine sit while they wait for
the
that
machine
check?
Sits while it waits.
Oh, really? Every time? Or based on the value of the part?
Yeah, every time.
And what do you expect turnaround time to be?
It varies from day to day. I mean, we might have 30 setups in a day. We might have 3, right? So, but it's, it can be a while. I mean, we have an internal expectation that during that setup time, or during that first article inspection time, like you're gathering your tools for the rest of the job, you're getting your whatever that might be. Maybe you're helping someone else with another setup, something like that. But yeah, all of our first articles go to the inspection department and get done in there.
Yeah.
So
I think that is a good debate to have, based on the value of the part or the cost of the raw materials. Like, what is the risk of starting production while you're waiting on the double check and your confidence level that your machinist was right?
And we've evolved in that for over the last several years as we've invested more in other tools, right? So like we have a hexagon laser arm. We have parts we've been running for 40 years. There's plus or minus 5 tolerances on them. In those cases where that's modeled and programmed, I mean, that first article inspection is a scan with the laser arm against a 3D model, a proven program. That's almost a go, no go first article at that point, right? It's just, is it green, yellow, or red? If it's green, keep right on going. But we don't let the machine run until at least a couple eyes have said, yeah, this is a good part.
Yeah. Okay, cool. That's good. And of course, probably goes without saying, anything you check with should be calibrated. Or if you don't have a formal calibration system, which every shop should, you should verify it against a standard immediately prior to use every time, right? Throw it on a 1-inch gauge block or whatever. If the part is 5 inches long, put it on a 5-inch gauge block or something before you do that. Of course, the more critical the dimensions are, but we want to avoid having a caliper mic that someone dropped on the floor and just put back on the bench and no one told anybody else about it. No,
there's no 5-second rule.
Checking parts. Yeah, there's no 5-second rule for micrometers.
You have to do that. You have to have some sort of like calibration process to pass ISO or anything like that anyway, right? So
for sure. Yeah, you do.
Like you just better get it right
But there's shops listening that aren't ISO certified.
Sure.
And, right. Or just setting up their system and having a full schedule of calibration and a system for how they happen and make sure they don't get out of calibration. And that is the best practice. And even then, it's probably still a good practice to have a standard right there with you check it on a gauge block right before you do some checking and make sure it didn't get dropped 2 minutes before and someone didn't tell you, or it just started to get out of tolerance for some reason.
I mean, you mentioned
Yeah.
design for manufacturing, and like some of this needs to be checked before you're checking it on a part, because oftentimes like you should be a bit skeptical about the tolerance in the first place. Like, why is this like clearance hole that tight? Like, why it's not even a critical dimension? Like, why this is going to make our part harder to make? It's going to make it more costly to make. We probably can't really charge them for it, but some student engineer put it together and just tolerance everything the same way, and now you got to figure it out. So it's important check too.
And do that up at the quoting stage.
Yeah.
And be like, here's our price as drawn, and here's our price if you loosen up these tolerances.
Yeah.
Right.
And we take a pretty firm stance in house that, once. So like, I want my inspectors to be very black and white. It's good or it's not. I've heard too many times, form, fit, and function, it's okay, until the customer gets it and they're looking at it black and white, right? So our thing is, no, it's either to print or it's not. And if it's not, or if there's a way it could be, to your point, Nick, on the design for manufacturability, that needs to happen before it hits the floor. Once we've agreed to make something, that's what we're making.
Mm-hmm.
Right.
Yeah, we had an issue where we made a bunch of grid plates, and there was some tolerance that was totally irrelevant, but we missed it.
Right.
And then the quality person at the customer is just like, hey, this is wrong. We want to send them all back. And we had a big Teams call, and they were like, no, all right, we'll take it. It's fine. No big deal. But like, we should have caught that before we even missed a tolerance that was an irrelevant tolerance.
Yeah. And to that point too, I mean, I think, maybe the expansion of that from, it's gone to your floor, your inspection department is very black and white. It's good or it's not. When I first bought Hill Manufacturing, we would not, if something was bad, but we thought it might be good, we didn't even ask the customer, right? I mean, all of my customers have a pretty formalized deviation process. Don't be scared to use that. I mean, we used to be scared to use it. Oh, we don't want to tell them that maybe we made a bad part. So we would just remake the part. Well, I bet you it'd probably be interesting to go back and look, but I would guess 3/4 of the time that we ask for a deviation, we get it. And it's still a good part. And you work with the engineers, you work with their quality department to determine what is acceptable for this part that, maybe we can't quite get to that surface finish, or some bore that's, does it really need to be plus or minus 0.2, or is 0.3 okay?
Yeah, you don't want to overuse the deviation process, but you don't want to underuse it either. Like, it costs money to make it again. So,
right.
Yeah, good point.
So we have made parts, we have validated the process, we have checked them as they've been running. One thing that we always did at ProCNC was, if we were doing, say, a 10% inspection on an operation, we wouldn't just fully do the in process. And of course, you've decided which dimensions to check in process based on your process control of your tools, your work holding, the tolerance themselves, the material. So that in and of itself, of course, is an art. But once you've decided which dimensions to check, and your customer might flow down the requirements of how often, or what AQL level they want checked. But once you've defined which things to check, if you're doing 10%, for example, we didn't just fully check every 10th part. We checked every single part that came off for some of the dimensions on the in-process check. So let's say we were doing a part with 30, it has 500 dimensions in total, and we're checking 50 of them in process. We might check 10 dimensions, or call it, just for easy math, 5 dimensions on every single part, and rotate through the 50 until we've checked all 50 dimensions every 10th part, right? But every single part is getting their eyeballs close on it. We're looking at it, we're checking some of those dimensions. But it catches things like, maybe you got a burr in your fixture that's now leaving an imprint on the part. But if you're not looking at every single piece, you're not going to find that until possibly the 10th part later, and you might have 9 bad parts. So I think it's a good practice. It also works, Nick, you'll love it. It works really well in a lean flow. because the amount of inspection time isn't higher every 10th part. You build in a tiny bit every single cycle, and you can balance your standard work combination.
You can hijunka. Right? You can level the workload.
There you go.
I got some Japanese words you've never even heard of.
I want to explore that with you, Paul, at some point, because that's not something we do. But one thing we've done in determining like our IPC, just the structure by which we do.
Yep.
And I don't know it off the top of my head. Hopefully everybody else does. But if it's under 10 parts, we just check every part. Like we IPC every part. And then so we have a matrix is my point. I mean, it's it shouldn't always be 10%. If you're only making 10 parts, you only check one, you're gonna be in trouble.
That's not good enough. Yeah.
So we just have like a matrix if it's and we actually it's partly dependent on quantity and it's partly dependent on value of the part, right? So it kind of meshes out.
It's like a risk matrix.
Yeah. And then my other thing that we put in that I think helped us a lot is, we run some parts that might have a 4-hour cycle. You're only getting 2 parts a day. And maybe we're running 20 of those and we only need to check 5, right?
Mm-hmm.
Well, that doesn't mean I want you checking parts every 3 days.
Sure, of course.
So there's a time element in there too for us that, and actually we kind of say everybody needs to do at least one IPC an hour.
Mm-hmm.
So if your part's 4 hours, go check someone else's part. Go do an IPC on someone else's part 4 times while you're doing that too.
Yeah. Oh,
and
cool.
We've tried to also have a culture of those kind of cross checks just throughout the day anyway. So like you're expected to check 2 other people's parts today.
Yeah.
Right. So
yeah.
Once in the morning, once in the afternoon, go just randomly check someone else's parts and make sure that we're putting good parts on the floor.
That's cool.
That's a great idea. I love that teamwork aspect. Everyone's working together, checking each other's parts.
Well, and it took a while to get there, but actually the first time that one of the guys found, this was like 3 or 4 years ago, the first time that someone found a bad part on someone else's pallet that they had not found, in the next shop meeting, I gave that person a $100 bill.
Nice.
And guess what? Everybody wanted to find bad parts all of a sudden.
See, so it works if you love your colleagues or if you hate them.
Yeah. So there was
you could be the biggest tattletale in the shop.
Right.
you're rolling in bank.
Yeah.
Everyone hates you and you're rich.
Right. So it became like this hunt though, right? Like everybody wanted to find bad parts.
It's a witch hunt.
Somebody else had run.
That's great. That's great.
We talk so much about culture, right? So, and I mean, that's just one of those things. I mean, it just reinforces a culture of quality.
Yeah. If you have a good culture, it's like, you got me on that one, man. Shoot, you're going to get that $100. That's cool.
Yeah. That's great. That's a great one. Definitely a takeaway for others. All right. So we've checked our parts. We know we got good quality all through the run from the beginning to the end. We've already talked about outgoing and incoming inspection. I know for some of our clients that make really high value parts, and even back in our shop, if you have a part that's, hundreds of dollars or thousands of dollars, do 100% camera inspection every time they leave. Like take pictures of every part, attach them right into the system, and then your outside processor's like, oh, these were dinged up when we got them from you guys. It's like, no, they weren't.
Yeah, take a picture of exactly how it was packaged before you close the crate and ship it too.
Yep, for sure. Packaging is a huge one.
That's a good one.
Yeah, and then check them when they come back, so you know that things are still good. And then generally, if you don't have anything else to do like assembly, which if you do assembly, you should be checking those things as well, of course. But then it comes down to sort of final and document package preparation. And so I'm curious to hear from you, Mike. On final, there's always seems to be this debate. Do you actually take a part out and do a 100% final inspection on a piece and make a report, and that's what you do internally? Or do you review the inspection results that you had throughout the run, do a sampling inspection on some critical key features, visuals, things like that? Yeah, what do you guys do?
I'm glad you asked, because for 7 years now, I'm still waiting for somebody internally to define final inspection. Because, and I've asked you, I've asked, people at Pro Shop, I've asked other shops, I've asked my internal team, and everybody has a completely different definition of what final inspection should mean. I would say we've generally taken the approach that if we can look at the system and, we use Pro Shop. So if we can look and see that the first articles are complete on every operation and the IPCs are complete on every operation, our final inspection does not necessarily need to involve measurement.
Mm-hmm.
Right.
Yep.
I mean, there are instances where it still does. Maybe we're going to quickly run a thread gauge, through some, something like that, a go no go gauge on something like that. But generally, I think we've perfected. Well, we certainly have not perfected our quality process, but we are comfortable with our quality process. That final inspection does not mean measurement for us.
Mm-hmm.
It means everything else, right?
Right.
And do we have the right count?
Mm-hmm.
Is it packaged correctly? Is all the correct paperwork with it? If it's going on a semi to deliver 2 days from here, is it packaged differently than if it's going on our truck 15 minutes from here? Right.
Mm-hmm.
So final inspection for us does actually not include much measurement anymore, as much as it includes just everything else that we expect to deliver to our customer.
Yeah, that aligns with how I think of it. When your upfront quality processes are as robust as yours are, and it's highly unlikely that you have bad parts in that final box, then it shouldn't need to require inspection. Unless, again, like you just do a sampling, thread gauges, check, the super tight bore on a few things or whatever.
Sure.
Just for an extra little measure of confidence. But yeah, it's really about making sure that the entire deliverable to your customer is going to be absolutely perfect. We talked about this recently.
Yesterday, you and I talked about it. Yeah.
Was that on a podcast?
That was on the Modern Machine Shop show.
Oh, yes, the webinar.
Yeah.
Of course. Thank you.
Oh, the one you guys invited me to? Cool. Thanks. Yeah, I had so much fun. It was great.
Yeah. Nick, you had some great points. Yeah. Yeah, like if you send, a package of parts and the paperwork isn't right, it's going to deviate out of their normal process, go to MRB and delay your payment. But it also gives you a ding on your quality because, these days with any kind of, higher echelon type of client, a regulated industry, the paperwork matters just as much, if not more, than the parts themselves, right? It's got to be perfect.
Yeah, to repeat what we talked about yesterday, beyond the fact of the analogy I'll give is, at least with most of my clients, so if I'm getting paid in 30, 60, 90 days, whatever, you hear about 120, 150, that clock doesn't start until everything we just talked about is complete, right? So if it hits the dock and the paperwork's not correct, until the paperwork's correct, they don't receive the invoice. And then the clock on your net 90 doesn't start until they receive the invoice, right? So it's as critical as piece of everything. I mean, we need to get paid, right? I mean, I think all of us are in the business of getting paid. So this part of the process is as important as that first article at the saw. Are we cutting this at the right length to make a good part?
Right. Yep, absolutely. It's and this is also where what's in your document package, how it's formatted, even where in your packaging you put it. That's all part of having this concept that, I feel like I speak about ad nauseum. The E-Myth concept, building a franchise prototype, doing everything exactly the same way every time that your customer wants to get it, like that McDonald's hamburger, right? You make the paperwork totally perfect for each individual customer and their preferences, right? And we build a whole system for doing that in our tool. But the concept is that if they say they want a copy of the packing slip outside the box and inside the box, put that into your system and make sure you do that every time, right? If they want a first article in the AS9102 format, you got to make sure you're formatting it that way every time. Or if they want you to email it in advance of the shipping the package so they can start looking at it early, you got to do that too. Right. So build it into your process to make sure you get it super consistent, and that builds trust, and then that builds more orders.
Yeah. Yeah, and there's your internal and your external quality expectations, right? So like everything we just talked about, this customer requires these things, a COC and the material certs, whatever. But you also, I think, as part of that entire delivery, you need to think about your own internal expectations of quality.
Mm-hmm.
So,
Mm-hmm.
like we talked about on a show recently, that like we wrap our pallets in yellow shrink wrap. Totally minor thing, right? It's not a big deal, but it's our thing. So, is that pallet wrapped in yellow shrink tape? Do we have netting on any part with OD threads? Like those are just things we do that are still part of the quality process, even though it's not on the print.
Right. And that's part of quality control, which is what we're talking about today. Right.
Right.
Yeah. I love it. That's great.
Hey guys, it's Nick, and I'm so excited about Machine Shop Mastery being part of Making Chips. So my good friend Paul Van Meter, he's been a partner, he's been a sponsor, he's been a friend, and he's been involved with Making Chips for a long time. And now his podcast that I love is part of our group. Here's why you should listen to it. Paul doesn't just run a software ERP company for machine shop leaders. Paul was a machine shop leader. He loves machine shop leaders. He's the one leading the charge to thank all the machinists out there for all the incredible work they do. And the best thing about him is he actually knows how to make their incredible work turn into an incredible business. So when you listen to Machine Shop Mastery, you're going to hear Paul and his guests talk about exactly what they've done to overcome their challenges and make their business successful. You're going to get those kind of like heart-wrenching stories that tell you what people have been through that you can resonate with, things that you can empathize with because you're a manufacturing leader too. So check out Machine Shop Mastery and learn how to master your machine shop, hosted by my good friend Paul Van Meter under the Making Chips Network. So I think we're a little bit out of our time tolerance here for our quality control. We can wrap up. I'll say what my...
It was give or take 10 minutes.
Yeah, okay, got it. Plus or minus 10. My kind of takeaway is like how holistic it is. It's not just checking parts. It's cross-functional. It starts in quoting or even before that sometimes. And take a holistic approach to achieving quality excellence would be my main takeaway. What about you guys?
Yeah, that's a good summary.
No, I think that's perfect.
Yeah. I mean, we only talked for about 45 minutes. We could talk for at least another hour plus and not even cover all the other topics. So just scratch the surface of it. But hopefully some good takeaways. Yeah, be holistic. Everyone owns it. Build it into your culture. People should take pride in the quality that your shop is delivering. And if they're not taking pride, you need to relook at why.
Mm-hmm. Yeah, if your people aren't taking pride in quality, you're not making chips.
And if you're not making chips,
you're not making money.
Bam.